Hello everyone, welcome back again. Today we will be covering part 6 in our Big O playlist in computer science. So if you would like to refer the previous parts, then in my playlist there is part by part description, and you can start listening to starting from part 1 till part 5, wherein we mostly covered about what Big O notation is, and then we basically looked into big O, big omega, big theta, best case, worst case, expected case complexities, as well as time complexity, space complexity, amortized complexity, and then we also went through few examples, the Java code for analyzing the time and space complexity for recursive calls. So today in part 6 in this series, we will be covering one question. Here we have to determine the runtime of the given algorithm or given logic. So in general, I would highly recommend to learn this concept very well, because on day-to-day basis, in especially in software development, when we are writing the code, then it is really important to understand how it is going to perform. Then the code will run in production, right? So as well, this is a really useful concept to learn in computer science world, because fundamentally we are able to analyze how the code actually runs and how we can improve its efficiency or its runtime or its space complexity. As well, this is a very important topic in competitive exams, wherein you will find lots of questions about finding the runtime or the complexity or time or space complexity of a given code or algorithm. So overall, in a nutshell, I would say start learning it, and the more questions you solve, the better the understanding will be. And as well, generally, what happens is, if you learn some common patterns and how its complexity has come up. Like, for example, there are a few very common time complexities or space complexities, like uh, order of 1, order of log n, order of n, order of n square, order of 2 raised to the power n, order of square root of n, n log n, like that. So, and the ordering of these different complexities, like which one is better in terms of time, which we have already covered in previous parts of this series. Then you can actually, whenever you are writing any logic or code, then it will automatically trigger you that, okay, what is the complexity coming in here, and is there any way I can reduce its complexity? Okay, so let's get started with that. So this is the question. So we are given a method, okay, and in this method accepts an array. So basically, whenever you and you have to determine its time complexity, right? So first of all, please understand what the complexity we have to find, because there are two parallel concepts. One is time complexity and the other one is space complexity. In previous parts of this series, we learned a bit about both type of complexities. So just to recap on that, so time complexity is also known as a runtime of an algorithm or logic or code or method, whatever you say it. So basically, time complexity is about timing. So how much time a given algorithm is going to take, right? And then space complexity is about space. So how much memory it's going to consume. So it is very much important to first carefully make a note which complexity we have to find in a given question. So in this, it's the runtime. So somebody might ask, what is the runtime of this program, right? So how you are going to start it? So always basically check from the start, like which parameters we are given in a method or in a program, and then what we are doing in each step. Okay, and you also need to make a note of or analyze the full logic of the given program. It's not that you will find something like, for example, for loop. So you are given an array and you have given a for loop, and then you simply uh, choose the answer as order of one, for example, order of n, for example, right? So it's not the case, because we also looked at some examples in previous part of the playlist, wherein we were saying that sometimes the complexity is, for example, order of n square plus n. So maybe in step one, it's n square or n, let's say it's n. And then in later part, after few lines, we have again one more code wherein the complexity is coming as order of n square, right? So in that way, it's going to be n square, not n, because as we had seen previously in previous parts of the series, we should always look out for tightest bound on the runtime. Tightest bound means like, is there any scenario or is there any scenario where it will take most more time, right? So kind of worst case scenario. So that is few points we have to keep in mind before jumping quickly on the solution and on the answer, choosing the answer part. So with that, let's get started on this. So I will here walk you through how I will do it, and then maybe uh, because everyone's approach can be different, right? So I am explaining here my approach, how I am going to derive its runtime or its time complexity. So basically, we are given this array. So what we are doing is we are initially defining some variables. So we have defined a variable sum, then we have defined a variable called product with initial value of sum as 0 and product as 1. So it means somewhere, so let me just take one pen as well. So basically, this is our, let's say, memory, right? So I have a variable called sum. So I will just denote it as S. And then I have another variable called product. So here I have it 0, then I have it 1, right? So then what I am doing is, so then we have a for loop, right? So in this for loop, what we are doing is we start with index I, right? 0, and then I go through till array dot length, right? So I am having a for loop where I is going from 0 to full array, right? And I plus plus. So I am iterating through each element in this array and doing some sum, right? Sum is equal to sum plus this. So ultimately, now one more important concept is that you do not need to always solve the whatever value will come. For example, in this case, sum. So after this for loop finishes, whatever will be the value of sum. So it doesn't really matter from the complexity point of view. So what we need to make a note is here in this step, this is a for loop. And in this for loop, I am iterating through full array length for each element of the array. So in this scenario, the time or runtime is going to be order of n, because if n is the size of the array, then I am going through each element of the array and doing something, right? Then likewise, if we go, so this is over. So this for loop is over now. So we have made a note that the complexity or runtime of this code segment is order of n. Then we have another next block, right? So in this also, again, we iterate through same array, starting from 0, incrementing it one by one, and then picking up the value of the array right here, and then doing the product. So in this case as well, it's just a single for loop, iterating through each element of the same array, right? So in this case as well, the complexity is order of n. And one more important point is this first for loop and second for loop, they are independent. So first one first finishes and then the second one finishes. And finally, I have sys out, right? So essentially, like, these two things will be order of just one, because these are the constants kind of complexities, right? We are we are just defining the variable in memory, so it's constant. It will run in the constant time. Likewise this and likewise this, right? Here I am not doing anything like that. So overall, we have gone through the full logic what we have in this method, and looking at this, so we can see the tightest bound is coming as order of n, right? So technically speaking, the complexity is here going to be order of n plus order of n, right? Which will come out as order of 2n. But we can drop the constant as we learned previously. So the complexity is going to be order of n. So that's how we are going to evaluate the complexity here or runtime here, right? So this is what uh, is my approach going to be. Okay, I hope it was clear. So let's see what the answer is. It's order of n. Yeah, and I guess that's it for today. So I will be sharing few more examples in later part of this series. Till then, keep learning and have fun. Thank you.